Alright, so today we're going to be going over basic differential properties. So as we know, if y equals to ax raised to the n power, we know that the first derivative of y with respect to x will equal to n times ax to the n minus 1. So this is a nice property that we are going to denote. Also, instead of writing partial y, partial x, we could simply write f prime of x. Just another way of denoting the same thing. So let's go through some examples. And admittingly, a large part of today's lesson is figuring out how do we rewrite our original statement to something that looks like this, so that way we can apply this nice differential property to it. So if we have f of x equals to x cubed, then we know that f prime of x will equal to 3 times x raised to the second power. And then if we wanted to punch in some values, so f prime of negative 2 will equal to 3 times negative 2 raised to the second power, which equals a positive 12. So the slope of our original f of x function will equal 12 when x equals negative 2. Alright, let's do another one. If g of x equals to 5 x raised to the 10th power, g prime of x will equal to 10 times 5x to the 9th power, which equals to 50x to the 9th power. Alright, let's do another example. If k of x equals to x raised to the negative 3rd power, well, we're still going to apply the same rules, is that we're going to multiply by the exponent, and then we're going to reduce the exponent by 1. It's just that now k prime of x will equal to negative 3x. Well, negative 3 minus 1 will be negative 4. Alright, if n of x equals to 1 over x to the 7th power, well, it's going to be worth it to us to rewrite this equation so that denominator is now in the numerator. So we're going to use some properties that we know about exponents, and we know that this is equal to x raised to the negative 7th power. And now we can apply the nice rules that we know. N prime of x will equal to negative 7x to the negative 8th, or n prime of x equals to negative 7 all divided by x raised to the positive 8. So using some manipulation of properties of exponents and where it belongs in the numerator denominator of this fraction can allow us to be able to apply that rule that we know. So one last example. If m of x equals to the square root of x, well, we can rewrite square root of x as x to the 0.5 power. So that means m prime of x will equal to 0.5 times x. What's 0.5 minus 1? Well, it's negative 0.5. And that will equal to 0.5 all over x to the positive 0.5. Or we could rewrite this as 0.5 over the square root of x. Alright, so a lot of what we're going to be doing is figuring out how can we rewrite our original statement into something that we can be able to easily take the derivative of. So let's think about an example about a company's sales. And how might we use the first derivative to discuss a company's sales. So let's assume the company's sales, S sub t, where t is representing the total number of months that have passed by. So the sales for this company will equal to 0.1 t cubed plus 0.5 t squared plus 2t plus 3. So this big old equation tells us, representing the company's total sales given as a function of t, where t represents each month passing by. Well, now we can figure out what s prime of t will equal to. Well, that equals to 0.3t squared plus t plus 2. So that is s of t and s of t, s prime of t. And then we can figure out what s of 5 equals to. What is the total amount of sales during month 5 equal to? Well, we can plug that back into our original s of t equation, and we'll get 0.1 times 5 cubed plus 0.5 times 5 squared plus 2 times 5 plus 3. Well, 5 cubed is 125. 0.1 of 125 is 12.5. Plus 5 squared is 25. Half of 25, once again, is 12.5. Plus 10 plus 3. Well, this all equals to 38. So what's the total number of sales that this company has 5 months into it? Well, 5 months later, this company has sales of a total of 38. Well, we can also figure out what's s prime of 5. What is the marginal rate of sales at 5 months? Well, we can plug that into our equation. We'll get 0.3 times 5 squared plus 5 plus 2. And I got that by plugging 5 in for that s prime of t equation. And we are going to get 7.5 plus 5 plus 2 equals to 14.5. That is what s prime of 5 equals to. So, how can we write a sentence that incorporates this 2 bits of information? So we know at 5 months, total sales equals to 38 sales, and total sales will increase by 14.5 by next month, because that's what that S prime equation represents. Is represent what's the change in total sales given a 1 unit change in T. So at 5 months, our total sales is $38, and we know at 5 months, our monthly sales is changing by 14.5. All right, so that does it for today's lesson.